The purpose of this video is to give an example of how to work with a projectile that has been launched at an angle where you are given the initial speed. So in this problem we have a human cannonball is launched at a speed of 33 meters per second at an angle of 40 degrees above the horizontal. The mouth of the cannon is 4 meters above the ground and the net will be placed at this same height. So I would recommend always beginning with a picture. So the mouth of the cannon is 4 meters above ground, and the initial velocity is 33 meters per second at an angle of 40 degrees. And this person is going to fly out through the air, and then we want to have a net at this same height above ground. So also at 4 meters. How far away from the mouth of the cannon should the net be placed? So we are looking for this distance here, from the mouth of the cannon to the net. So whenever you are working with projectiles, always set up your list of variables with a horizontal list and a vertical list. Horizontally, we have constant velocity. Vertically, we have constant acceleration, with the acceleration being free fall. So the horizontal variables are going to be the horizontal displacement, the horizontal velocity, which is constant, and the time interval. Vertically, we have the vertical displacement, the initial component vertically of the initial velocity, the vertical component of the final velocity at some later time, the acceleration, and the time. Then we need to figure out what values we know. I do not know the horizontal displacement, so I do not know delta x. The horizontal velocity, that is going to be a component of this initial velocity. So let's go ahead and take a closer look at the initial velocity. The initial velocity is 33 meters per second, but that velocity has a horizontal component to it and a vertical component to it. The horizontal component stays constant throughout the entire motion of the projectile. So I'm going to call that just Vx. I don't need to put an initial or a final on there because it's going to have the same value at every time in the problem. Vertically though, this projectile starts out going upward. So this is going to be the y component of the initial velocity. Now we need to calculate these components. This angle is 40 degrees, and we can use our sine and cosine functions to calculate this. So let's start with cosine. Using SOHCAHTOA, that reminds me that cosine is adjacent over hypotenuse. So now I'm going to look at my triangle and look at what's adjacent to the angle. It's going to be Vx, and the hypotenuse is that initial velocity. So solving this for Vx, I would have Vx equals Vi cosine theta. Vi was 33 meters per second times cosine of 40. And calculating that is 25.3 meters per second. Okay, so that tells me the horizontal component of the initial velocity, and that horizontal component stays the same for the whole problem. Then I need to find the vertical component of this initial velocity. Let's try the sine function. Sine is opposite over hypotenuse, so opposite is VIY over the hypotenuse. So VIY equals VI sine theta. The initial velocity is 33 meters per second times the sine of the angle. So calculating that gives us 33 times the sine of 40 is 21.2. So this goes here. Okay, and remember the meaning of this is that it's the vertical part of the initial velocity. Well, what else do we know? We know that the acceleration is negative 9.8 meters per second squared because vertically the motion is just like free fall. And I must know something else because over here I would need at least 2 values in order to find the third. Over here I need 3 values in order to find a 4th value. So I don't know the time, I don't know the velocity at any later time. What about delta y? Well, it starts at this height and it lands at the same height. So the vertical displacement during the time I'm looking at is going to be 0 because it lands at the same height that it started at. Okay, now what are we looking for? How far away from the mouth of the cannon should the net be placed? That is a horizontal distance. That is going to be this. So this is what I'm looking for. But I can't find that because I don't know the time. But if I could find the time that it gets to this vertical displacement of 0, that's the same time that it gets to this horizontal displacement, and then I could find that. So I'm going to need to use my vertical list of variables first to find the time, and then I can substitute it over here. So I need the equation that has no VFY. So that would be delta x equals V initial y delta t plus 1/2 a delta t squared. Substituting my values, I have to put in this initial vertical velocity. And we see that there's a delta t and a delta t squared. So I can factor out one of those. So leaving me with 21.2 minus 4.9 delta t. And then as long as delta t is not 0, I can divide both sides by delta t. And that gives me 0 equals 21.2 minus 4.9 delta t. And let's add 4.9 delta t to both sides. And now divide both sides by 4.9, which gives me a delta t of 4.3 seconds. So think about what your answers mean. Going back to the picture, this is the time it takes for it to go from this height back to the same height. So that's the time it takes to land in the net. And what we're looking for is where the net should be placed. So now, if I know the time here, that's going to be the same time here. And now we can use our constant velocity equation to find the horizontal displacement. So the horizontal velocity, the rate at which it's moving to the right, is 25.3 times 4.3 seconds, which comes out to be 109 meters. So the key idea here is that when you have an initial velocity at an angle, you need to find the horizontal and the vertical components of that initial velocity, because the horizontal component is your constant horizontal velocity for the sideways aspect of the motion, and the vertical part of that is the initial velocity vertically. And then you can substitute those things into your list of variables in the appropriate place. What would happen if the initial velocity was downward? Suppose a gun is shot from a cliff at a downward angle. And let's say this is 30 degrees. Well, in that case, your Vx is still to the right, but your V initial y is going to have a negative sign. So when you substitute it, you would need to put a negative in there with that component.